And we're talking about question number 3. Okay, so question number 3 states, okay, you've got, so it states that you've got an impure barium hydroxide. Okay, so first thing, number 3, question 3 starts with an impure barium hydroxide. So there is impure barium hydroxide. Ba is 2 plus OH is -1, so it's BaOH twice. And it's got a mass of how much? 1.6524 grams. 1.6524 grams. And then it states that it's allowed to react with 100 cm cube of hydrochloric acid. So it reacts with HCl. You must know your equations. When it reacts with HCl, what will happen is that there's going to be barium chloride that's going to be formed. Okay, that is BaCl2 plus water. Okay, that's your first reaction. So this is the part that we did. Okay, barium hydroxide. I'll just underline this. Reacts with 100 cm cube of hydrochloric acid, and it's got a concentration as well of 0.2 mole per dm cube. So the volume is known. That's 100 cm cube, and at the same time, you're also given the concentration, which is what is the concentration? 0.2 mole per dm cube. So all of this, that's written above. And the reaction happens. And if you know, and you can balance the equation, it's going to be 2HCl. And there would be, I think, 2 water molecules as well. The oxygens are 2, so on the other side, there are 2 oxygens, so that's fine. So that's what's happening. He then says when the excess of the acid was titrated against, so the acid is in excess. So that means, what that means is there's going to be leftover acid. So this is being added in excess, and there's going to be leftover acid. So there's some leftover HCl. And what happens to the leftover HCl? What he says is the acid was titrated against sodium hydroxide, and 10.9 cm cube of sodium hydroxide were required. So the HCl was titrated with sodium hydroxide. And how much was required? The volume of sodium hydroxide that was needed to react with the excess acid, the leftover acid, was 10.9 cm cube. So we know that, and it then states, I mean, you know the equation as well. What happens when HCl reacts with NaOH? It produces NaCl plus water. So after that, what then he states is that 25 cm cube of the sodium hydroxide required, 28.5 cm cube of hydrochloric acid in separate titration. Calculate the percent. So there's now again, this is a question that we did in the past paper as well. It's similar to that. So he says that in a separate titration, so in a completely separate titration, he says there's another reaction where he does HCl with NaOH, the same HCl with the same NaOH. And it goes on to form NaCl and H2O again. And this time he states that 28.5 cm cube of hydrochloric acid was required to react with 25 cm cube. So this is 28.5 cm cube. And this is 25 cm cube. So let me just check the values. So let's move over here now. Solve everything over here. Remember, you have to figure out the purity of barium hydroxide. That's what you're looking for. The purity of barium hydroxide. So the question is, he took impure barium hydroxide, reacted with an excess of HCl, and whatever HCl is left after the first reaction, that reacted with an NaOH, and the volume that was needed for was this one. And he then states that in a completely separate reaction, the same HCl, which is 0.2 mole per dm cube. So they've already given that the same HCl, which is 0.2 mole per dm cube, needed 25 cm cube of it needed 25 cm cube of NaOH to react with it. So the question now is what can you do? The first thing is you can find the moles of HCl that you added over here. The only thing, just a second. So what you can do is you can find the moles of HCl that you added over here. So the only thing you have to do is just apply moles is concentration times volume. Can somebody quickly tell me how many moles you're getting?
0.02. 0.02.
अच्छा एक मैं वो देख लूं कि वैल्यूज तो गलत नहीं है 0.02 moles, right? तो इसका मतलब है कि the moles that you added in excess, that's 0.02 moles, right? Now these are not the moles that are going to react with barium hydroxide. These are the moles that were added. There's going to be some leftover HCl, but you can't find the leftover HCl because you can't find the moles of NaOH because by only using volume you can't find moles. You need concentration as well. So in this separate experiment is going to be helpful in that. I mean, you can find the concentration of NaOH that you're using for which you did this separate experiment. Can you find the moles of HCl over here? I mean, what are the moles of HCl that you're getting in this separate experiment? Kya, if you do concentration times volume, what do you get?
0.005.
नहीं exact नहीं.
Sir, 0.142 पता नहीं मैं.
हाँ वो तो कुछ तो होगा. I mean, it's 28.5 into 0.2 divided by 1000. मेरे calculator किधर है?
5.7 into 10 power minus 3.
So you're getting 5.7 into 10 power minus 3 moles, right? So according to the equation, the ratio is 1:1. So the moles of NaOH would be exactly the same as well. So that's going to be 5.7 times 10 power minus 3 moles as well. And so for NaOH, what you know is you know the moles and you know the volume. So what you can do is you can find the concentration because apply the same formula. It's going to be concentration would be moles over volume. So apply the same formula. Moles is concentration times volume. So concentration would be moles over volume. And if you do that, it's going to be 5.7 times 10 power minus 3 moles. And they are going to be divided by the volume, which should be in dm cube. So it's going to be 0.025 dm cube, I think. I mean, what is
0.22 grams. 0.228.
0.228 mole per dm cube. Right? Is this clear? So what we did over here was that in this separate experiment, he told us that HCl, this much volume was used. And you figured out the moles of HCl and the moles of NaOH would be exactly the same. So you had the moles of NaOH and you had the volume of NaOH as well. That was given in the question. So if you had moles and volume, you can find the concentration, which comes out to be this. So is this clear up till this point?
Yes, sir.
So now you're going to take this concentration because remember he did the separate experiment using the same HCl and same NaOH. So you're going to take this concentration. This is the concentration of the NaOH that you're using in the experiment, which is 0.228. So I'm going to write that concentration over here with the. So it's 0.228 mole per dm cube. Now, can you find the moles of NaOH, this one?
2.5 into 10 raised to power 3 minus 3.
The exact 2.5?
नहीं सर वो 2.485 है तो मैंने 2.4
नहीं अभी तो let's keep it exact अभी ना 2.485 into 10 power minus
3
minus 3 moles, right? So you've figured out the moles of NaOH, you had the volume and concentration. The moles of HCl, the leftover HCl would be exactly the same. So it's going to be 2.485 because it's 1:1. So it's going to be 10 power minus 3 moles, right? And so now the question is easy. Now, these are the moles that you added initially. These are the moles that were added for HCl. And these are the moles that are left at the end of the reaction. So how many moles of HCl actually took part in the reaction? So
0.0175.
0.01.
75.
So this
सर यहाँ पर ऐसे भी तो फाइंड कर सकते थे एक्सेस अगर बेरियम का ये जो पहले से हमें मास दिया हुआ उसकी मोल्स फाइंड करके
impure है ना, that's you can't use moles. So you can't use
impurity यूज नहीं कर सकते
नहीं क्योंकि this is not the mass of barium hydroxide ना, क्योंकि बीच में impurity भी शामिल है ना, तो अब वो बीच में नहीं डाल सकते ना, वो उसका क्या करो, तो you can't use this, मतलब इसको आप you can't apply any formulas to this, ठीक है, clear है?
तो मतलब सर किसी भी उस पे हमने HCl का फाइंड नहीं कर सकते मोल्स इस वाले से
हाँ क्योंकि impure है ना, तो ये barium hydroxide की तो mass है नहीं है, ये तो barium hydroxide plus something is added to it, we don't know what, लेकिन वो तो उसकी भी बीच में mass शामिल है ना, ठीक है? अच्छा, anyways, in this question, initially you found out that this is 0.02 moles and you found the leftover HCl. So all you had to do was take 0.02 moles and subtract the leftover HCl, which is 2.485 into 10 to the minus 3. And you'll find the moles of HCl that actually took part in the reaction, which came out to be 0.0175. Ye clear, Salwa? Is this clear, this thing? Dua, Amna, is this clear? Oswa, Reid, Rizwan, clear?
Yes, sir.
Achha, so now the question is easy. You found the moles of HCl. So the moles of barium hydroxide is going to be 2:1. I mean, 2 HCls react with 1 barium. So divide this by half, and you'll have the moles of barium hydroxide. What do you get if you divide this by half?
8.757 into 10 raised to power minus 3.
Okay, 8.75?
75775 into 10 raised to power minus 3.
Minus 3 moles. But akhir kaam mein you find the mass, because you have to find the purity. So mass can be found by moles multiplied by MR. So I'm not sure what the MR, I think barium is 137. 137.3, I think. Let me just check barium. Barium atomic mass. So that's it's 137.3. So barium is 137. So it's 8.757 into 10 to the minus 3. That's moles multiplied by the MR. What is the MR? That's OH is 17 into 234, so that's 137.3 plus 16 plus 1 into 2, that's 34. So that's the MR, which is 167.3. So multiply the 2, you'll find the mass. What is the mass that you're getting?
$1.465.
Okay, so is the idea we did all the calculation 1.465. So we kind of did all the calculations correctly because our value is coming out to be less than 1.6524. So you can now find the percentage purity, which is going to be what is percentage? It's 1.465 grams out of 1.6524 grams. That's pure into 100. And you'll get your percentage, which is what?
$88.665.
Okay, so you're getting 88.6%. So ये हो गया. Rizwan, clear? This question is done, right?
Yes, sir.
मेरा ख्याल था I think 2 was ये 1 वाला तो हमने वैसे भी किया था उस तरह का. So it's actually ठीक है. So that's this. We can even try some harder, क्योंकि remember theory के अंदर you get questions like these. So किधर गई हमारी? We had a book. Just a second. Is it किधर गई? Calculations. So we did these questions. Most of these are very, very similar. So let's move to past papers again. Back to past papers. These were the tough ones. Where's a past paper? I saw this one. Let's find out some other theory question, which is I think we did this. Okay, X. Let's try and do the X ones. Okay, you have to figure out water of crystallization. So that's another type of question which you get in structured. So how do you figure out X? So we'll try and do that. So the question is, there's 5.13 grams of washing soda crystals, and washing soda crystals, they contain sodium carbonate. So basically you have 5.13 grams of Na2CO3.XH2O. And you have no idea how much water of crystallization there is. And it then states that it's dissolved in water in the solution is made up to 250 cm cube. So you now have a 250 cm cube. You've mixed it in water and you have a 250 cm cube solution. Basically, that's sodium carbonate aqueous. And then what he does is that he takes 25 cm cube of this solution. So 25 cm cube of this solution is taken. Just a small tiny sample which contains Na2CO3 aqueous. And he reacts it with what? He reacts it with hydrochloric acid, which is 35.8 cm cube. तो ऊपर से ना वो डाल देते हैं HCl. So HCl is added, and that is 35.8 cm cube, and the volume that he's using is, sorry, the volume is 35.8 cm cube, and the concentration that he's using is 0.1 mole per decimeter cube. So that's the whole question. That he took crystals where you don't know how much water is present, that's unknown, and he mixes with the water, makes it into a solution, takes 25 cm cube of the sample and titrates it. He's asking for the equation. So what's the equation when a carbonate reacts with HCl? It's going to produce NaCl in this case, plus that's the salt, water, and carbon dioxide. The only thing you have to balance, it's I think 2 Na and 2 Cls. So it's a balanced equation, and he's asking calculate the amount in moles of HCl that you're using. So here's your HCl that you're using. So you have you can find the moles. It's concentration times volume. So it's going to be 35.8 divided by 1000 multiplied by the concentration, which is 0.1. What do you get?
3.58 into 10 raised to power minus 3.
So you're getting 3.58 into 10 to the power minus
3.
Minus 3 moles. And uske baad he's going to ask you about the moles of this. So So he's asking, use your answer to calculate the amount in moles of Na2CO3 in the 25 cm cube. So what's the ratio? HCl, you find the moles of HCl. So the moles of Na2CO3 are going to be half of this. So what is half of this?
So 1.79 into 10 raised to power minus 3.
Minus 3 moles. So it's basically into 10 to the power minus 3 divided by 2. That's it. That's your working. So you've found the moles of Na2CO3 and they are coming out to be, let me just add it over here. They're coming out to be 1.79 times 10 to the power minus 3. In the next step, he's definitely going to ask you, KB, in 25 cm cube, you had this much moles. So in 250 cm cube, which is the original sample, how many moles would there be? So he's asking for the moles in 250 cm cube. So you figured out that in 25 cm cube solution that you titrated, you found that it had 1.79 times 10 to the power minus 3 moles of moles of Na2CO3. So the original 250 cm cube is going to have how many moles? That's going to be X, or basically it's going to be 10 times more. So the answer is going to come out to be 1.79 into 10 to the power minus 2 moles. Is this clear?
Yes, sir.
So you found the moles of sodium. Yes.
सर उसको आपने सीएम क्यूब को डीएम क्यूब में कन्वर्ट किया था
नहीं किया था
अभी वाले में अच्छा
नहीं वो
डायरेक्ट आंसर
क्योंकि वो रेशियो था जरूरत नहीं थी कि यू जस्ट हैव टू फिगर आउट के मतलब कर भी दो उसको 1000 से डिवाइड करो इसको भी करो तो इट डजंट इट्स नॉट नीडेड है ठीक है वो है कि मोल्स का जब फॉर्मूला लगाते हो ना तब जरूरत है ठीक है अच्छा अब ये कि you found the moles of the crystals that you added सारे crystals इसी में ऐड किए थे ना so what you can now do is you found the moles over here it's 1.79 into 10 to the power minus 2 so he's going to what is he asking now he's asking you to calculate the mass of Na2CO3 so you know कि Na2CO3 के moles कितने थे उस crystal में it's 1.79 times 10 to the power minus 2 right So multiplied by the MR, which is क्या बनती है CO3 12 plus 16
minus 3 नहीं था
हाँ
so minus 3 नहीं था 10 raised to power minus 3
लेकिन वो 250 में वो तो उसमें थे ना वो जो 25 cm क्यूब सैंपल नहीं था उसमें था 1.79 into 10 to the power minus 3 जब वो 250 में निकाले थे तो वो तो 10 टाइम्स ज्यादा थे ना
ओके सर
ठीक है और मतलब इसी सैंपल में वो सारा क्रिस्टल था ना तो ये मोल्स उसी के है ना क्लियर है वो -3 इसमें था वो जो टाइट्रेशन में 25 cm की जो छोटा सैंपल यूज किया था ठीक है अच्छा अभी है कि उसको MR से मल्टीप्लाई कर दो तो कार्बन इज 12 ऑक्सीजन 16 into 348 plus 12 that's 60 60 plus 23 plus 23 that's going to be 106 तो ये उसकी MR है तो what is the mass of sodium carbonate
so 1.897
so you're getting 1.897
so ये हमने 250 cm क्यूब वाला यूज किया ना इसमें
हाँ क्योंकि वो क्रिस्टल की बात कर रहे हैं ना वो क्रिस्टल जो थे वो सारे के सारे किसमें डाले थे उस 250 cm क्यूब सॉल्यूशन में थे ना
अच्छा ठीक है और बाद में 25 किया था
हाँ टाइट्रेशन में यूज किया था वो तो सिर्फ इसका 1/10 हमने सिर्फ इस्तेमाल किया था ना ठीक है
सर
अच्छा अब ये कि यहाँ तक तो आ गया वो कह रहे कि x की वैल्यू निकालो तो अब उसने कहा है कि वॉशिंग सोडा क्रिस्टल जो था वो उसकी मास क्या थी 5. वो उसने शुरू में बताई थी इट वाज 5.13 ये बिल्कुल स्टार्ट में पहली चीज उसने बताई थी जिसके अंदर वाटर भी शामिल था एंड वी फिगर्ड आउट कि जी सोडियम कार्बोनेट की जो मास है ना वो कितनी है दैट्स 1.897 ग्राम्स राइट तो वाटर की मास कितनी है the total crystal has a mass of 5.13 grams. Sodium carbonate
3.23
3.23 0.23 grams. So remember, the entire crystal had a mass of 5.13 grams. By titration and doing everything, we figured out that the mass of just sodium carbonate was 1.897 grams. So the only thing that's left is 5.13 minutes. You subtract 1.897 and you get 3.23 grams. That would be the mass of water. यहाँ तक clear है? Is this clear? यहाँ तक clear है सारों को? So अब आखिरी काम रह गया कि what you got to do is you've got to find the ratio. Remember, X is the ratio. Okay, if you had 1 mole of sodium carbonate, how many water molecules would there be? So for sodium carbonate, you already know the moles. It's I mean, उसी से तो mass निकाली थी. It's 1.79 into 10 to the minus 2 moles, right? So you know the moles. It's 1.79 times 10 to the minus. For water, how many moles is this? Divide 3.23 by 18. What do you get?
So 0.179.
So you're getting 0.179 moles. So what is this ratio? Like, if you had 1 over here, तो यहाँ पे कितने होंगे? X. So what is this ratio? Like X would be 0.179 divided by 1.79 times 10 to the minus 2. So I think it would come out to be 10. ये क्या ratio बन रहा है? I mean, just have to figure this out. I mean, this ratio is, I think it's 1:10. Is this clear? And I can do this explicitly that it's
तो
one.
ऐसे नहीं कर सकते कि हम लोएस्ट वाले से जो इन दोनों में से छोटे उनसे डिवाइड कर लें?
हाँ मतलब हाँ वो भी कर सकते हैं. empirical formula में तो यही करते हैं. दोनों में
इसमें भी कर सकते हैं.
हाँ या तो रेशियो लगा लो या वो कर लो, एक ही बात है. ठीक है. So the value comes out to be 10. अच्छा मैं लास्ट पार्ट फिर से एक्सप्लेन करूं कि नहीं ऑस्वा यहाँ तक इज दिस क्लियर कि यहाँ तक इसके सोडियम कार्बोनेट कितने मोल्स थे? वाटर के मोल्स, वी फाउंड द मास ऑफ वाटर, वी फाउंड आउट द मोल्स, राइट? अच्छा, now the only thing is you have to convert this into a whole number ratio, because what this means is that if you have 1 sodium carbonate, how many water molecules would be with it? It's 1:x, right? So we figure out kind of if you have this much, I mean, you just have to use ratios like 1.79 into 10 to the minus 2. तो उसका रेशियो क्या है? वाटर का क्या? I mean, this is sodium carbonate. So what is the amount of water? It's 0.179 moles. So how do you convert this into 1? You divide by 1.79 times 10 to the minus 2. उसको भी उसी से divide कर दो. So this would become 1 and this would become 10. इसका मतलब है कि 1 sodium carbonate has 10 water molecules to go with it.
Sir?
हाँ जी.
Sir, ये जो आपको क्वेश्चन है कि use your calculations to determine the value of x, तो इस क्वेश्चन में एक दफा मतलब मास का वो पूछा गया था, तो इसमें हमें कैसे पता चलेगा वो मोल्स के बारे में पूछा या मास के बारे में? लाइक कंपैरिजन कैसे होती है उनकी?
अच्छा, रिमेंबर मास का कभी भी कोई कंपैरिजन नहीं होता. जो भी हमने पढ़ा था ना कि जो भी रेशियोज है ना, ये जितने भी रेशियोज हैं, ये सारे रेशियोज किस चीज के हैं? मोल्स के रेशियोज हैं. ठीक है, नंबर ऑफ पार्टिकल्स के. इट्स नेवर द रेशियो. मतलब कोई भी इक्वेशन, इफ यू पिक एनी इक्वेशन, व्हेन इट सेज के sodium carbonate 1 reacts with 2, it doesn't mean ke 1 gram reacts with 2 grams. It's not the ratio of the mass, it's the ratio of the moles. कि रेसिपी है ना कि एक ये डालो बीच में, 2 ये चीजें डाल दो. इन 2 की मास कुछ और हो सकती है, इसे एक की मास कुछ और हो सकती है. मास तो कोई भी हो सकती है ना, राइट?
यस सर.
कि मैं अगर कहूँ ना कि 2 सेब और एक, जैसा किचन में जाके एक डिश बना रहे हैं, उसमें 2 सेब हैं और 2 बीच में ना लेट्स से कोई वो क्या कोई और चीज ना, कोई 2 लेमन्स बीच में मिक्स करना है, ठीक है। तो क्वांटिटी तो दोनों की सेम है ना, दो दो, लेकिन मास तो दोनों की डिफरेंट है ना। तो 2 एप्पल्स में दे वुड हैव अ डिफरेंट मास, 2 lemons would have a different mass, right? तो remember, रेशियो कभी भी mass का रेशियो नहीं है, it's never the ratio of the mass, it's the ratio of the, मतलब ये जो 1 और 2 ये जो numbers लिखे होते हैं ना coefficient, this is the ratio of the moles, clear है?
Yes, sir.
तो यहाँ पे भी it's वो जो 1 रेशियो, मतलब एक सोडियम कार्बोनेट के साथ कितने वाटर मॉलिक्यूल्स हैं, ठीक है। आपने वो 1 रेशियो x निकालना है ना, कि 1 के साथ कितने होंगे, तो इट्स द रेशियो ऑफ द मोल्स। तो वी फाउंड आउट द मोल्स ऑफ बोथ, बस इसको 1 बनाना है, इसको 1 के साथ बनाओगे डिवाइड बाय द, या अगर इंपेरिकल फॉर्मुलाज याद है उसमें सिंपल काम क्या करते हो, दोनों में से जो छोटा है ना उससे डिवाइड कर दो, सो डिवाइड बोथ ऑफ देम बाय द सेम नंबर, तो द थिंग टर्न्स इनटू अ होल नंबर रेशियो, 1:10 आएगा। इज दिस क्लियर?
Yes, sir.
चलिए टाइट्रेशन में और इज ड्रिवन ऑफ,
Sir.
हाँ जी,
सर आप उस टाइप के क्वेश्चंस कराएंगे जिसमें PV इक्वल्स टू एनआरटी यूज हो रहा हो?
वो तो करेंगे, वो तो चैप्टर ही डिफरेंट है ना, वो भी करेंगे। अभी तो मोल्स के काफी सारे डिफरेंट टाइप्स के क्वेश्चन, सो टाइट्रेशन वाले तो मोस्टली खत्म हो गए हैं, ठीक है। अभी व्हाट वी आर गोइंग टू ट्राई एंड डू इज, ये वर्कशीट पता नहीं मैंने सेंड की है कि नहीं की, ट्राई गोइंग थ्रू, खासतौर पे ये जो थ्योरी के क्वेश्चन है इंपॉर्टेंट। अब इसमें जो डिफरेंट टाइप्स के ना, सो टुमारो वी विल प्रोबब्ली ट्राई एंड डू कंबशन एनालिसिस।
सर
हाँ जी,
सर आपने इस टॉपिक के एमसीक्यूज नहीं कराए तो क्या वो रिलेटिवली इजी है एज कम्पेयर टू थ्योरी?
नहीं अभी तो हमने ये टॉपिक किया ही नहीं है, अभी तो ये टॉपिक चल रहा है। अभी तो हमने खाली इस टॉपिक में जो सब टॉपिक्स है ना, अभी तो हमने खाली टाइट्रेशन और रीडॉक्स टाइट्रेशन, इन 2 के ही किए थे क्वेश्चंस खाली, और तो हमने किए कोई नहीं है। तो मतलब अभी तो ये बाकी पूरा टॉपिक रहता है, क्लियर है बात?
यस सर।
तो ये क्लिक नहीं हो रहा था इसे, हाँ। तो वैसे कंबशन एनालिसिस एमसीक्यूज ही होंगे, अब वो मिक्स होंगे। थ्योरी में इसलिए कह रहा था कि थ्योरी पहले कर लो, क्योंकि थ्योरी के क्वेश्चंस, एमसीक्यू तो 1 मार्क का होता है ना, वो तो चलो इंपॉर्टेंस वाइज इतना इंपॉर्टेंट नहीं होता जितना वो थ्योरी का जो 10 मार्क का 12 मार्क का क्वेश्चन है, दैट्स वे मोर इंपॉर्टेंट, ठीक है। तो इसलिए उसकी प्रैक्टिस ज्यादा करो। एमसीक्यूज फिर हम अब इसके बाद हम एमसीक्यूज ही करेंगे। तो रिमेंबर टुमारो विल डू कंबशन एनालिसिस, ठीक है। शुड आई सेंड द सेम क्वेश्चंस, क्योंकि इसके अंदर दे ऑल टाइप्स ऑफ क्वेश्चंस। एंड के ऊपर दिस थ्योरी, मतलब इसी वर्कशीट के अंदर कहाँ गया, ये लिखा हुआ है, इट्स दीस आर थ्योरी क्वेश्चंस, वो शुरू में दे ऑल एमसीक्यूज, सो I'll send the same worksheet, ठीक है। अच्छा, anyways, I'll just briefly give you an overview of what we'll do tomorrow, and it's related to moles. The idea is, now there's this type of question, ठीक है, it's again a moles question. Now the idea is that when you burn something, especially a hydrocarbon, so whenever you burn a hydrocarbon, so that results in the production of carbon dioxide and water. And I'm burning butane over here, so there's going to be 4 carbon dioxide, there's going to be 5 water molecules, and if I add up the oxygens, there's going to be 8 plus 5, that's 13. So this is 13 by 2. Yeah, 6.5. Achha, so the idea is combustion analysis ka, कि whenever you burn something, it burns in a very specific ratio. Okay, whenever I burn butane, there's going to be 4 carbon dioxide, 5 water molecules, and 6.5 oxygens would be used up. If I burn some other compound, let's say I burn butene, then the amount of carbon dioxide and the amount of water, everything would be produced in a different ratio. For example, 4 carbon dioxide, 4 water molecules, and that's 4 2s are 8, 8 plus 4, that's so there's going to be 6 O2s. So the idea is, by just looking at the ratio in which the quantities are getting produced, I can figure out the formula of the hydrocarbon. That's the basic idea of combustion analysis. Okay, if you know okay, how much oxygen got used up, how much carbon dioxide was produced, how much water was produced, you should be able to figure out the formula of the hydrocarbon. And every hydrocarbon is going to have a different ratio. ठीक है? Is the idea clear? Question तो हम कल देखेंगे किस तरह करना है. तो ये फिर हम कल करेंगे, ठीक है?
Sir,
Yes.
मैंने पूछा था कि वो जो ऑर्गेनिक केमिस्ट्री करनी
हाँ.
थी वो कब
वो
करेंगे?
वो हमने करनी है 15 डेज के अंदर अंदर. मतलब ये अभी हमारा कौन सा चल रहा है लिस्ट में, कौन सा ये? हम असल में वेट करें क्योंकि असल में प्रॉब्लम है कि बहुत से लोगों के ना एग्जाम्स चल रहे हैं अभी. So I'll start that in probably 2 weeks, 3 weeks, ठीक है?
Okay.
क्योंकि वो सबसे इम्पोर्टेंट है.
Sir?
ठीक, हाँ जी.
सर जो 4 दिसंबर को जो आपने लेक्चर किया था वो आप अपलोड कर सकते हैं?
4 जनवरी वो मैं कर देता हूँ.
हाँ सॉरी 4 जनवरी, सॉरी 4 जनवरी.
मैं भेज देता हूँ, ठीक है?
ओके सर.
वैसे उसको देख लिया करो, YouTube को देख लिया करो, उसके ऊपर ना आ रहा होता है वो मेगा लेक्चर वाला ना, उस पर ऑटोमेटिकली प्रॉब्ली. लेकिन मैं भेज देता हूँ, अभी भेज देता हूँ, ठीक है? चले ठीक है, ओके, ठीक है, अल्लाह हाफिज.